Hi, hello, my dear students. A very good evening to all of you. So, warm welcome to Master NTSE program. In last classes, we have discussed the some problems with respect to the chapter functions. So now we are going to continue those problems. So now we are doing the problems related to the functions. So already I told you in sets, from sets, relations and functions, these three topics, one question may be given in NTSE examination. Out of 20 questions in mathematics, one question may come from sets or relations or functions. So that's why you have to concentrate on it. So moreover, and you have to concentrate more on your state board 9th and 10th syllabus. So the questions mostly will be given from 9th and 10th standard syllabus. Okay. Now let us start the class today. So here the domain of 1 by square root of 16 minus x square. So already we did some problems, 17 problems in the last class. So this is the 18th problem. The domain of 1 by square root of 16 minus x square. So here by observing the denominator is square root of 16 minus x square. 16 minus x square. We know the value under square root is defined when that is 0 or more than 0, means positive. If the value under square root is negative, then we can't define the square root of that value. But here by observing 16 minus x square lies in the denominator. When the square root lies in the denominator, we have to consider the positive value only, don't consider 0. In place of 16 minus x square, if we take 0, 1 by root 0. So root 0 is nothing but 0 only, that cannot be defined. So that's why we must take 16 minus x square greater than 0 when the function is in the form of 1 by square root of f of x. If the given function is of the form 1 by square root of f of x, we have to take f of x greater than 0. In place of f of x, we have 16 minus x square. Here from 16 minus x square, by taking minus as common, you will get minus of x square minus 16 greater than 0. If you multiply on both sides by minus, minus of minus plus, that is x square minus 16 less than 0. X square minus 16 less than 0. Again x square minus 16 can be written as x plus 4 into x minus 4 less than 0. So we know the formula, if alpha comma beta belongs to R and alpha less than beta, then x minus alpha into x minus beta less than 0, that implies x belongs to open interval alpha beta. So we have this formula where alpha comma beta are real numbers and alpha less than beta. So if we have x minus alpha into x minus beta less than 0, then we can express like this: x belongs to open interval alpha beta. Here x plus 4 is there, but here we have x minus alpha is there. So to make x plus 4 as in the form of x minus alpha, here we can express x plus 4 as x minus of minus 4 into x minus 4 less than 0. So we can write x plus 4 as x minus of minus 4 into x minus 4 less than 0. Now this is in the form of x minus alpha into x minus beta less than 0, where alpha equal to minus 4, beta equal to 4. Alpha equal to minus 4, beta equal to 4, clearly alpha less than beta. So the formula is x belongs to alpha beta. So that is minus 4 comma 4. By observing, we can take option C. So the domain of the given function is, so therefore domain of the given function is square root of minus 4 comma 4. By observing, here we have minus 4 comma 4 in option C and in option D also. But by observing the brackets, here we have the open bracket, here we have the closed bracket. If you have the bracket like this, then we can take the values between minus 4 comma 4 only. If you have the bracket like this, then we can consider all values between minus 4 comma 4, including minus 4 comma 4. So how can we take this bracket or this bracket? If the given expression contain only less than 0 or greater than 0, then we can take the bracket like this. If the given expression contains less than or equal to 0 or greater than or equal to 0, then we can take this bracket. Okay. So for the given function, the domain of 1 by square root of 16 minus x square, the domain is minus 4 comma 4 open interval. So take the screenshot of this slide. Let us go to the next problem. So after completing every problem, take the screenshot. After completing the class, take a separate notebook and copy all the screenshots which you have taken during the class. Now next, let us go to the next problem. So these are functions of the chapter name. Here the domain of f of x equal to log of x minus 3 into 6 minus x is. Here options are given as a 3 comma infinity, b 3 comma 6, c 0 comma infinity, and option D is minus infinity comma infinity. Minus infinity means all the negative real numbers. Negative real numbers means left side of 0. Plus infinity means positive real numbers, all the numbers right side of 0. Here the given function is f of x equal to log of x minus 3 into 6 minus x. Log of x minus 3 into 6 minus x. So for this function, we have to find the domain. We know the logarithmic functions are defined only for positive real numbers. If negative number is there or 0 is there, then we can't define logarithm for that function. So to define a logarithm, the number must be 0 point something. So the logarithms are defined only for positive real numbers. So that's why here log of x minus 3 into 6 minus x is defined if x minus 3 into 6 minus x is greater than 0. So log x to the base a is defined if x greater than a. If x greater than a. So that's why in place of x we have x minus 3 into 6 minus x. So log f of x is defined. Log f of x is defined if f of x greater than 0. So that is the formula. So log f of x is defined if f of x is greater than 0, not equal to 0. So log f of x, log f of x, whatever the base may be, log f of x is defined. Log f of x is defined if f of x is greater than 0. Log f of x is defined if f of x greater than 0. Here if we compare log of x minus 3 into 6 minus x with log f of x, in place of f of x we have x minus 3 into 6 minus x. So f of x greater than 0 means we can take x minus 3 into 6 minus x greater than 0. X minus 3 into 6 minus x greater than 0. Here if we take minus as common, x minus 3 into minus of x minus 6 greater than 0. So this can be written as minus of x minus 3 into x minus 6 greater than 0. So but here minus is there. So to cancel that minus, let us multiply on both sides by minus 1. By multiplying on both sides by minus 1, we will get x minus 3 into x minus 6 less than 0. So by multiplying on both sides by minus 1, if less than is there, then that can be changed as greater than. If greater than is changed, then that can be changed as less than. So because minus 1 is greater than minus 2. If you multiply on both sides by minus, 1 less than 2. So here also x minus 3 into minus of x minus 6, by multiplying on both sides by minus 1, you will get x minus 3 into x minus 6 less than 0. Again this is in the form of x minus alpha into x minus beta less than 0. Again this is in the form of x minus alpha into x minus beta less than 0. So just like the above problem, if alpha comma beta are real numbers and alpha less than beta, then x minus alpha into x minus beta less than 0 means x belongs to open interval alpha comma beta. So from this we can write x belongs to open interval 3 comma 6. So we can take option B is the correct option. So therefore domain of the given function, log of x minus 3 into 6 minus 6 is 3 comma infinity. So that is option A. So remember, logarithmic functions are defined only for positive real number. So that's why log of x minus 3 into 6 minus 6 is defined only when x minus 3 into 6 minus x greater than 0. So by taking like that and simplifying, we have gotten 3 comma infinity, 3 comma 6. So the answer is 3 comma 6. So that is option B, not A. So 3 comma 6. So 3 comma 6. So x minus 3 into x minus 6 less than 0. X belongs to alpha beta 3 comma 6. So the domain is 3 comma 6. So option B is correct for the given problem. So take the screenshot of this problem. Next, let us go to the next problem. Now, the domain of f of x equal to square root of x minus 2 plus 1 by log of 4 minus x is. Options are given as A 2 comma infinity, option B minus infinity comma 4, option C 2 comma 3 union 3 comma 4, and option D 3 comma infinity. So, in the above problems also we have found the domain of the given functions, but in the above problems we have only single function. Here we have the two functions. Root x minus 2 is one function, 1 by log 4 minus x is another function. When we have more than one function, then we have to find the domain of each function, then we have to take the common domain. So we have to take the values of x which satisfy the given two functions, root x minus 2 and 1 by log 4 minus x. In the given problem, if we have the functions more than one, 2 functions, 3 functions, 4 functions like that, then find the domain of each function. After that, take the common domain of all those functions. So here the given function is f of x equal to square root of x minus 2 plus 1 by log 4 minus x to the base e. If base e is not there for logarithm, then we can take that is e. Here first let us consider x minus 2, where x minus 2 lies under square root. So we have to take x minus 2 greater than or equal to 0. X minus 2 greater than or equal to 0. So the value under square root is defined only when that is 0 or a positive number. So that's why in place of x minus 2 by taking 0, root 0 equal 0. In place of x minus 2 by taking positive real number, you will get some value. But if you take negative real number in place of x minus 2, then that is not defined. So that's why the value square root of x minus 2 is defined only when x minus 2 is greater than or equal to 0. X minus 2 greater than or equal to 0. If you take minus 2 to this side, x greater than or equal to 2. X greater than or equal to 2 means in place of x you may take 2. In place of x you may take 2 or more than 2, 2.1, 2.2, 2.5, 2.9, 3, 4 like that. Up to infinity you may take any value. So that's why where we can write x belongs to 2 comma infinity. Here we are considering 2 also. So that's why we have to take this bracket, and we are not considering infinity. For plus infinity and minus infinity, always we have to take the bracket like this. For plus infinity and minus infinity, always you have to take the bracket like this. So x belongs to 2 comma infinity. When in place of x by taking any value between 2 comma infinity, root x minus 2 will be defined. Next, one more function is there, that is 1 by log 4 minus x. So actually logarithmic functions are defined only for positive real numbers. So we can take 4 minus x greater than 0. But here 4 minus x must be not equal to 1. If you take 4 minus x equal to 1, log 1 equal to 0, whatever the base may be. If you take 4 minus x equal to 1, you will get 1 by log 1. Log 1 equal to 0, so 1 by 0. Something by 0 is infinity. Something by 0 means not defined. So that's why in place of 4 minus x, don't consider 1. In place of 4 minus x, don't consider 1. So 1 by log 4 minus x means 4 minus x greater than 0 and 4 minus x not equal to 1. If you take the second function 1 by log of 4 minus x. So for the second function, So 4 minus x greater than 0 and 4 minus x must be not equal to 1. If you take in place of 4 minus x 1 by log 1, log 1 is 0, 1 by 0 is infinity. So 4 minus x greater than 0 means by taking minus x to that side, 4 greater than x. Here if you take minus x to that side plus x, if you take 1 to the side 4 minus 1, so we can write x not equal to 3. You may take any value in place of x greater than 4, so less than 4. So 4 greater than x means x less than 4 and x not equal to 3. X less than 4 means you may take 3, 2, 1, 0, minus 1, minus 2, minus 3 up to minus infinity. But don't consider exactly x equal to 4. If you take x equal to 4, 4 minus 4 is 0. 4 minus 4 is 0. So that's why don't take x equal to 4. X not equal to 3. If you take x equal to 3, 4 minus 3 is 1. So 1 by log 1. Log 1 is again 0. 1 by 0 is infinity, not defined. So that's why don't consider x not equal to 3. You must take the values of x less than 4. So here x less than 4 means we can take x belongs to minus infinity comma 4. Here we are not considering 4. So that's why take the bracket like this. If we have strictly less than 0 or greater than 0, then we can take the brackets like this. If we have less than or equal to 0 or greater than or equal to 0, then we can take the square bracket. So now here x belongs to 2 comma infinity and x belongs to minus infinity comma 4 and x not equal to 3. X not equal to 3. Now we have to take the common domain. So by taking the real number line like this, so 0, 1, 2, 3, 4, so on plus infinity. We know all the numbers right side of 0 are positive real numbers, left side of 0 are negative real numbers, minus 1, minus 2, minus 3, so on, minus infinity. Now let us take this here, x belongs to 2 comma infinity. So this is 2, this is infinity. So x belongs to 2 comma infinity. Let us take this. X belongs to minus infinity comma 4. Here we are not considering 4. We are not considering 4. So that's why let us take the open bracket. So let us take like this. So minus infinity comma so 4. So we can take the shaded part like this. We can take the shaded part like this. Next also x not equal to 3. Here don't consider 3. Don't consider 3. So here by taking the common part only, common part means the mixed part of lines. So some lines we have taken like this, sometimes we have taken like this. Now common part means we have to take this part. So this part lies between 2 and 4. Here we are considering 2, but we are not considering 4 and we are not considering 3 also. So from this figure we can write x belongs to, we are considering 2 but not 3. So 2 comma 3 union, we are not considering 3, we are not considering 4 also. You may take any value between 2 comma 3 including 2, but don't consider 3. Between 3 comma 4 also you may take any value, but don't take x equal to 3 or 4. So 2 comma 3 union 3 comma 4 means that is option C. So therefore the domain of the given function, the domain of the given function equal to 2 comma 3 union 3 comma 4. Here the brackets are most important. In the remaining chapters you may take the bracket as your wish, but to find the domain and range of the given functions, these brackets are most important. If you take the bracket like this, we are considering 2 also. If you take the bracket, curve bracket like this, we are not considering those values. So but here we may take any value between 2 comma 3, here 3 comma 4. So in place of x, by taking any value between 2 comma 3 and 3 comma 4, the given function f of x is defined. The difference between the above problems and this problem is, in the above problems we have only one function, but here we have the combination of two functions. The first function is root x minus 2, the second function is 1 by log 4 minus x. When the given function contains more than one function, find the domain of each function. Find the domain of each function. After getting the domains of all functions, take the domain on the real number line and take the common part like this. So, for the given function f of x equal to square root of x minus 2 plus 1 by log 4 minus x, the domain is 2 comma 3 union 3 comma 4. So, that is option C. So, take the screenshot. Next problem. Now, among the following a 1-1 mapping is. So, 1-1 mapping is also known as injection, both are same. Among the following the 1-1 mapping is or injection is. So, first let us discuss what the definition of injection or what the definition of 1-1 mapping. Say function f maps a to b is said to be a 1-1 function. For different elements of A, we must have different images in the codomain B. For different elements of A means domain. If we suppose that f maps A to B is a function. Now, to say this function f from A to B is a 1-1 function or injection, different elements of A must have different images in B. Then we can say the function f from A to B is a 1-1 function. In 4 options, we have 4 different functions. If you take option A, f maps R2 are defined by f of x equal to x square plus 1. And option B, f maps R2 are defined by f of x equal to x square plus 2. If you take option C, f maps R2 are defined by f of x equal to x square minus 3. If you take option D, f maps R2 are defined by f of x equal to 3x plus 2. Here in every option, the function f is defined from R to R only, where R is the set of all real numbers. For all functions f, the domain is capital and the codomain is also capital. R is the set of real numbers. So, by taking different elements after simplifying, if we get the same image, then we can say that is not a 1-1 function. By taking different elements in the domain R, if we get different images in the codomain R, then we can say that is a 1-1 function. If we suppose that, first let us consider option A. So, by considering option A, here the function is given as f of x equal to x square plus 1, f of x equal to x square plus 1. Here in place of x, if we take 1, f of 1 equal to 1 square plus 1 equal to 2. In place of x, by writing minus 1 square 1 plus 1 equal to 2. So, by observing, by taking 2 different elements 1 comma minus 1, we have the same image 2. So, that is why we can say f maps R2 are defined by f of x equal to x square plus 1 is not a 1-1 function. So, therefore, f of 1 equal to f of minus 1 equal to 2. We are taking 2 different elements 1 comma minus 1, but after simplification we have f of 1 equal to 2, f of minus 1 equal to 2, same image. By taking 2 different elements 1 comma minus 1, we have gotten the same image 2. So, that is why f maps R to R is not 1-1 function. Therefore, f is not a 1-1 function. So, that is why we can eliminate option A. Similarly, by observing option B and C, here also we have f of x equal to x square plus 2. Here also we have f of x equal to x square minus 3. Similarly, in place of x, by writing minus 1 square 1 plus 2 3. If we take x equal to 1 square plus 1 plus 2 3. By taking 2 different elements, we are getting the same image. So, that is why option B is also not a 1-1 function. In option C also we have x square. In place of x, by writing positive real number or negative real number, x square minus 3. X square is always positive, again you will get the same value. So, that is why option C is also not a 1-1 functions. So, since the options A, B, C are not correct, then there exists only one option, that is D. So, we can take this is the option. So, similarly options B, comma C. Similarly, the functions in B, comma C Similarly, the functions in options B comma C are not 1 functions, or not 1 so AB's are not good, so directly we can take D. Or if you want to check whether it is a 1 function or not, here the function f of x equal 3x plus 2. In place of x, by taking different values, you will get different images. For example, if you take x equal to 1, 3 1 ja 3 plus 2, 5. If you take x equal to 0, 2. If you take x equal to minus 1, 3 into minus 1 minus 3 plus 2 minus 1. So, for different values of x, we are getting different images for f of x. So, that is why we can say f maps R2 are defined by f of x equal to 3x plus 2 is a 1 function. So, for all x belongs to R, or for different elements of x, for different values of x, for different values of x, so f of x equal to 3x plus 2. So, for different values of x, there exist different images, of f. So, that is why f is a 1 function. So, therefore, f is a 1 function. So, that is why option D. So, to check whether a function is a 1 function or not, so according to the definition of 1 function, a function f maps A to B is said to be a 1 function. For different elements of A, we must have different images in B. A function f maps A to B is said to be a 1 function. For different elements of A, we must have different images in B. If different elements of the domain A has different images in the codomain B, then we can say f is a function from A to B. So, by applying that condition to the given 4 options, A, B, C are not correct, because in place of x square, by writing positive value or negative value, we are getting the same value. So, that is why these 3 functions are not 1 functions, but in option D we have f of x equal to 3x plus 2. So, in place of x, by writing different values, we are getting different images. So, that is why we can say f of x equal to 3x plus 2 is a 1 function. So, option D is correct for the given problem. So, take the screenshot. So, next problem. Among the following, not an onto function. First, we have to check the definition of onto function. The onto function is also known as surjection. Onto function is also known as surjection. Here, by observing the options, option A, let f maps A, B, C to x, y, z be defined by f of A equal to x, f of B equal to y, f of C equal to y. So, according to the definition of onto function, a function f maps A to B is said to be an onto function. Every element of codomain B must have at least one pre-image in the domain A, or we may say like this: if the range equal to codomain, if the range of the given function is equal to codomain, then we can say the given function is a onto function. So, 2 definitions are there for onto function. How can we check whether the given function is onto or not? So, different all elements of codomain B. If you suppose that f is a function from A to B, all the elements of B, codomain B, must have at least one pre-image in A. That is one definition. Or for the given function f maps A to B, if the range equal to codomain, range is nothing but range of f equal to codomain means B. If these two are equal, then we can say f is an onto function from A to B, that is also called the surjection. If you take option A, let f maps A, B, C to x, y, z be defined by f of A equal to x, f of B equal to y, f of C equal to y. By observing this, clearly we can say the element Z has no pre-image. So that is why A is not correct. So, or if you take the diagram like this, here two sets are there. If you suppose that this is A, this is B, A contains the elements A, B, C, B contains the elements X, Y, Z according to the defined by f of A equal to X, A to X, f of B equal to Y, so B to Y, f of C is also Y. So here f is a function from A to B. By observing this, where range equal to X, Y only, but codomain equal to X, Y, Z. So range not equal to codomain, so f is not onto. F is not onto, so we can eliminate option A. Or by observing this diagram, the element Z doesn't have the pre-image in the domain A. The element Z doesn't have the pre-image in the domain A. So that's why this is not onto function. Or clearly we can say like this, range not equal to codomain. Range not equal to codomain, where range equal to X comma Y, codomain equal to X, Y, Z, both are not equal. So therefore F is not onto. F is not onto. So option A is eliminated. Next, if you take option B, let f maps n, so minus f maps n2 minus 1 comma 1 be defined by f of x equal to 1 if x is even, minus 1 if x is odd. If x is odd, here the function f is defined from n2 minus 1 comma 1. N means any natural number, also defined as f of x equal to 1 if x is even and minus 1 if x is odd. So n means 1, 2, 3, 4, 5, 6, so on, and the range is given as minus 1 comma 1. The range is given as minus 1 comma 1 be defined by f of x equal to 1 if x is even, minus 1 if x is odd. So for example, if we take n equal 1, 2, 3, 4, 5, 6, if we take x is even means 2, 4, 6, then we have to take f of x equal to 1. Next, if we take odd 1, 3, 5, then we can take f of x equal to minus 1. Clearly the range equal to codomain. The range equal to codomain, or every element of the codomain. Here the codomain contains only two elements minus 1 comma 1. Minus 1 has at least one pre-image and 1 is also has at least one pre-image. So option B is correct. So if we take, let f maps n to n minus 1 comma 1, if we take option B, here in n I am taking some elements. So this is n, if you suppose that this is some B. Here I am taking the elements 1, 2, 3, 4, 5, 6. You may take any number of elements because where the domain is n. The codomain contains only two elements minus 1 comma 1. F of x equal to 1 if x is even. So 2 to 1, 4 to 1, 6 to 1, and f of x equal to minus 1 if x is odd. So 1 to minus 1, 3 to minus 1 and 5 to minus 1. Here f is the function from n to b. By observing this figure where the codomain is minus 1 comma 1 and the range is also minus 1 comma 1. According to that, we can say f from n to b minus 1 comma 1 is an onto function, or every element of b. Here the codomain B contains only two elements, those are minus 1 comma 1. Minus 1 has pre-images, 1 has also pre-images. So every element of codomain must have at least one pre-image. According to this, minus 1 contains 3 pre-images, 1 contains 3 pre-images. So that's why f maps n to b is onto function or range equal to codomain. So for this option we can say range equal to codomain. So range equal to minus 1 comma 1, codomain is also minus 1 comma 1. So therefore f is onto function. So we can take, so option B is correct. Next, if you take option C, f maps R2 are defined by f of x equal to 2x plus 3. So f of x equal to 2x plus 3. So here in place of x, by taking different values, here the domain is R, the codomain is also R. For some elements in R, we may have the pre-image in the domain R. So that's why we can say this is an onto function. So we can eliminate option C. Option D is given as none of these. So with respect to the given 4 options, we can say f maps n2 minus 1 1 defined by f of x equal to 1 when n is even and f of x equal to minus 1 when x is odd. So this is the onto function according to this. By taking some elements in n 1 2 3 4 5 6, whatever the even number may be, we must map that to 1. Whatever the odd number may be in the domain n, we must map that to minus 1. So clearly from this we can say range equal to codomain. So f maps n2 minus 1 comma 1 is an onto function. To check whether the given function is onto or not. Two definitions are there. According to the first definition, a function f maps a to b is said to be an onto function. Every element of B must have at least one pre-image in the domain A. Second function is range equal to codomain. For the given function f maps a to b, the codomain is b. If that is equal to f of a, then we can say the function is an onto function. So by applying that definition to the given 4 options, we are getting option B is correct. So take the screenshot of this slide. So next, so among the following not a bijection, here 4 options are given. So bijection, a function is said to be a bijection if it is both 1 1 and onto. A function f maps a to b is said to be a bijection if it is both 1 1 function and onto function. If that is 1 1 not onto, then we can say that is not a bijection. If the function is onto but not 1 1, then we can say that is not a bijection. A function which is both 1 1 and onto function, then only we can say that is a bijection. So by observing option A, f is given as x comma a, y comma b, z comma c. The image of x is a, the image of y is b, the image of z is c. So here if we take the diagram, if we suppose that this is A, this is B, I am checking option A, where domain A contains the elements x, y, z, the codomain B contains the elements A, B, C. According to the mapping of the image of x is A, the image of y is B, the image of z is C with respect to the function f. So by taking different elements in the domain A, we have different images in codomain B. So clearly this is an 1 1 function. Next, by taking the codomain, we have ABC. By taking the range, again we have ABC. So range equal to codomain. So this is both 1 1 and onto function. So option A is a bijection. If we take option B, f of x equal to 3x minus 2. In place of x, by taking different values, you will get that is a 1 1 function, but you may get that is not a 1 1 function, onto function. If you take defined f maps R2 are defined by f of x equal to x square plus 2 in place of x by taking positive real number or negative real number, x square is always positive. So that's why this is not a 1 1 function. Next, if you take option D, f maps R2 are be defined by f of x equal to x cube. In place of x, by taking different numbers, you will get f is a 1 1 function but not onto function. In place of x, by taking different values, you will get range not equal to codomain. So that's why options B, C, D are eliminated. Only option A is correct. So a function f maps a to b is said to be a bijection if it is both 1 1 and onto. A function which is both 1 1 and onto is known as a function f maps a to b is said to be a 1 1 function, onto function, or bijection if it is both 1 1 and onto. So by observing the given 4 options, only in option A, that is f maps x comma a, y comma b, z comma c, the image of x is A, the image of y is B, the image of z is C. Only option A is satisfying the 2 definitions, 1 1 function and onto function. So that's why we can say this is a bijection. So take the screenshot of this slide. Let's go to the next problem. If f of x equal to 2x minus 1 by x minus 2 equal to y, so f of x equal to y, then f inverse of x equal to, f inverse of x is nothing but inverse of a function. The inverse of f is defined only when f is a bijection. If f maps a to b is a bijection, if f maps a to b is a bijection, then f inverse maps b to a is called the inverse function of f. If f maps a to b is a bijection, then f inverse maps b to a is called the inverse of f. If f maps a to b is a bijection, then f inverse maps b to a is also a bijection. So if f of x equal to y, if we suppose that f of x equal to y, then x equal to f inverse of y. If we suppose that f of x equal to y, from that we can write x equal to f inverse of y. So this is the definition of inverse function. If f maps a to b is a bijection, then f inverse maps b to a is known as the inverse function. F is a function from a to b. The inverse of f is b to a. For f, the domain is a, the codomain is b. For the inverse of f, the domain is b and the codomain is a. To find the inverse of the given function, we have to take f of x equal to y. We have to take f of x equal to y. So from that we can write x equal to f inverse of y. According to the problem, we have f of x equal to 2x minus 1 by x minus 2 equal to y. So we have 2x minus 1 by x minus 2 equal to y. 2x minus 1 by x minus 2 equal to y, where y is nothing but f of x. Here by cross multiplying, you will get 2x minus 1 equal to, so 2x minus 1 equal to y into x minus y into 2, or x into y minus 2y. If you take xy to this side, if you take minus 1 to this side, so 2x minus xy equal to, by taking minus 1 to this side, we can write 1 minus 2y. Here by taking x as common, 2 minus y equal to 1 minus 2y. 1 minus 2y. So from this we can write x equal to 1 minus 2y by 2 minus y. So x equal to 1 minus 2y by 2 minus y. Here we have to find f inverse of x. We have to find f inverse of x. If f of x equal to y, then x can be written as f inverse of y. So in place of x, by writing f inverse of y, so that is 1 minus 2 by 2 minus y. But according to the problem, we have to find f inverse of x. We have to find f inverse of x, but here we have f inverse of y. To get f inverse of x, in place of y, write x. So put y equal to x. So what we get? F inverse of x equal to 1 minus 2x by 2 minus x. So by observing the options, we have, that is option B. Here the given function is f of x equal to 2x minus 1 by x minus 2, that is also given as y. Then f inverse of x equal to, according to the definition of inverse function, a function f maps a to b is said to be an inverse function. So to define the inverse of the given function must be a bijection. If we suppose that f maps a to b is a bijection, then the inverse of f, that is f inverse maps b to a. If f maps a to b is a bijection, then f inverse maps b to a is known as the bijection. For the function f, the domain is a, the codomain is b. But for the inverse of f, the domain is b and the codomain is a. To find the inverse of the given function, we have to take f of x equal to y. If you take f of x equal to y, from this we can write x equal to f inverse of y. So by taking 2x minus 1 by x minus 2 equal to y, by cross multiplying and by writing the similar terms at one place, 2x minus xy equal to, if you take minus 1 to this side plus 1, 1 minus 2y, take x as common, 2 minus y equal to 1 minus 2y. So from this we can get x equal to 1 minus 2y by 2 minus y. x can be written as f inverse of y. So, f inverse of y equal to 1 minus 2y by 2 minus y, but according to the problem we have to find f inverse of x. To get f inverse of x in place of y, let us write x. So, put y equal to x. So, f inverse of x equal to 1 minus x by 2 minus x. So, we can take option B is correct. So, dear students, hope you understood the class today. Let us do some more problems related to the functions in the next class. So, thank you for watching my class and thank you for subscribing F Master. So, thank you very much.